Hey guys, my name is Ryan. I'm a tutor in the Econ Tutoring Center. Today I'm going to go over a little bit of review of derivatives and some of the basic tools of derivatives that you'll have to know for upper division economics. Remember that the language and notation by professor might change, so always check to make sure that the language and notation that we're using is the same as yours. Okay, so the three major things I'm going to try and go over today that you'll probably run into in upper division econ at some point are the power rule, the product rule, and taking derivatives of natural logs or ln's. So sometimes this ln might be expressed just as log, but usually that's what they mean. I'll get into that in a second though. So first of all, the power rule, that's when we have a function, some function, like say f of x equals x to the n, right, where n is just some number. We could take the derivative of that by taking f prime of x equals n times x, and then we subtract 1 from this power, right, so into the negative 1. So for example, if we had, let's say, f of x equals x squared, then the derivative f prime of x would be, I move the 2 to the front, like I did here, and then I subtract 1 from the power of x, so x to the 1, which is just x. So the derivative of x squared is just equal to 2x, right? A handy trick that you can use so that you don't have to use something else called the quotient rule is if you have something like this. You can use the same concept for negative powers, right? So if I have, let's say, the derivative 1 over x plus 1, and I want to take the derivative of this, right, then I can take, so this is f of x, right, and I want to find f of x, f prime of x. Well, the nice thing is I can rewrite this as x plus 1 to the negative 1, right? So now this is in a form like the previous one where I can just move the power to the front and subtract 1, right? So now I do this, I move the power negative 1 to the front, and then I subtract 1 off of this thing, x plus 1, but now to the negative 2. Right, so that's equal to negative 1 over x plus 1 squared. Now that I'm thinking about it, it's important to remember that sometimes you have to multiply this by the derivative of the inside, which is something we call the chain rule, that I could probably talk about in a later video. But in this case, in the simple case where the derivative of this inside is just 1, you can use this trick where you move the power to the front instead of having to remember how to do the quotient rule. So that's a handy trick with the power rule. Okay, so now we'll go into the product rule, which is something valuable. Okay, so let's say that's when I have, you know, f of x is equal to some function, let's say h of x, multiplied by another function, g of x, right? So we have two things multiplied by each other that we can't easily separate or combine into one equation, right? Well then, the power rule, or the product rule rather, says that f prime of x, the derivative of this, is equal to h prime of x, g of x, plus h of x, g prime of x. Right? And that looks confusing and hard, but I'll give you an example here that makes it a bit easier. So let's just say in this case that that f of x is equal to x squared times x plus 1. Right? And obviously we could distribute this and get our answer, or we could just use this product rule. So then using the product rule we get f prime of x. So this is going to be our h of x and this is our g of x. So then h prime of x is 2x using the power rule, and we just leave this g of x here, right? So x plus 1. Right, now we add h of x, which is x squared, times the derivative of g of x, which is the derivative of x plus 1, which is just 1, because this is a constant that goes away, and the derivative of x is 1, so we just get that. Right, so the derivative of f prime of x, or of this equation using this function or another, using the product rule, is this right here, which you could simplify if you wanted to, but it's still correct in this form. So that's another useful tool that you might run across. Okay. And now the last one that I want to talk about is taking derivatives of the natural log. And I actually might give you an example where we have to use the chain rule here, and maybe we'll use this as a good example. Okay, so here's what we have. We have f of x is equal to ln of x. Right, remember ln of x is the particular log base e, right? That f prime of x is equal to 1 over x, right? So we use this general idea for anything of the form ln of x. So let's say that I have f of x is equal to ln of 2x. Right, in this case, I'm going to have to use what I called the chain rule before. So I do the same thing as I did before, where I did f prime of x is equal to first 1 over 2x. But now I have to multiply this by the derivative of the inside. So that's, I can call this the chain rule here, add this on, right? And that's where if I have f of g of x, right, then the derivative of this is okay, so I'm sorry, if this is like h of x equals some function with another function on the inside, right? So ln is a function and there's a function on the inside which is 2x. I can take h prime of x by doing f prime, so the derivative of the outside function first, times the derivative of the inside function, g prime of x. Right? So in this case, I take the derivative of the outside function is just 1 over 2x, times the derivative of the inside function, which is 2. So then the 2's cancel, and you get just 1 over x again. So it turns out that the derivative of ln of x is the same as the derivative of ln of 2x. So I give you a little sneak preview of the chain rule here, but again, these are just some basic tools that you're going to want to use when finding derivatives of functions in upper division economics. So if you have any more questions, come into the Econ Tutoring Center.